limiting reagent. This is also, I would look at this as a variation of the stoichiometry type problems. Well, let me give you an overview of what the problem is. Let's say you mix two things and they're not in the proper proportion. How much are you going to get? For example, let's take a very simple, I'm going to call this a reaction. 2 breads plus 1 meat goes to 1 sandwich. Ready? So let's do the stoichiometry on that. If I start out with 12 breads, how many sandwiches can I get? Box equals star, I said start out with. So how many sandwiches can I get starting with 12 breads, which I'll just put BR, it's so hard to type. Okay, sandwiches, I'll put those over 1. Okay, so what do I have to do? I have a one-step conversion. I have to go from bread to sandwiches. And what's my conversion factor? I know for every 2 breads, I get 1 sandwich. Now, I know you could do this in your head, but I'm just trying to illustrate this for you. I guess I'm going to have to go back to my writing tablet and just go very slow. Nope, that's not going to work. Oh, that's really unfortunate. Right. Okay, so what do we get? 12 divided by 2 is 6, so you can see you're going to get 6 sandwiches. Okay, well, let's try another one. How about meat? How many sandwiches can I make from 5 meats? Well, let's see. How many sandwiches can I get starting with 5 meats? Okay, what do I know? I know for every 1 meat, you're going to make 1 sandwich. Yep, and I can see units cross off. I'm looking for sandwich, and I've got sandwiches. That's how I know to stop. When the unit you're looking for on the left shows up on the right. Okay, same thing here. Let me diverge. Bread canceled out. I was looking for sandwiches, and I kept doing my conversion until I came up with the unit I'm looking for. So let's go back to this one. Is equal to 5 sandwiches. Uh-oh, Houston, we have a problem. One of these says I can calculate 6 sandwiches. The other calculation says I can calculate 5 sandwiches. Only one can be true. What we have here is a problem of limiting reagents. And that is, one material is in short supply. An example would be, what if you had 0 meats? How many sandwiches are you going to make? Oh, I'm going to go with 0. Okay, I don't care how much bread you got. You're not making a sandwich. So here's the idea. If you don't have the things in exact, the reagents in exact proportion, then you're going to get different calculations depending on which one you start with. But only one can give us the true theoretical value, because there's only one true theoretical value. And it's this. You can make no more material than you can make no more product than the reagent that is in least supply. How do you know which one's in least supply? You do this calculation and you pick the one that gives you the smallest number. So according to bread, I have enough bread to make 6 sandwiches. I only have enough meat to make 5 sandwiches. Therefore, I can only make 5 sandwiches. Another analogy might be this. You can make no more material than the thing that is in least supply. That makes sense. If you've only got 2 slices of bread, you're only going to make 1 sandwich. Yeah? So if this were 2, then you could make 1 sandwich. How many sandwiches could you make at that point? Only 1. Why? Because bread's limiting. So in the case shown here, meat would be called your limiting reagent. Now we come full circle. Limiting reagent. Why? It's the reagent, the reactant that limits how much you can make. Okay, so with that, the concept is pretty easy. Next thing I'm going to have to show you is how you calculate that for a chemistry problem. instead of a sandwich problem. And let's see what I have here. Okay, so before I get going, let me tell you on a test, there could be three types of limiting reagent problems. One is where it just says, what's the limiting reagent? In this case, what's the limiting reagent? In this particular case, the limiting reagent was meat. Okay, why? Because starting with meat gave us the lowest amount of sandwiches. Okay, what is the material that's in excess? Well, once you calculate what's limiting, the other reagent must be in what's called in excess. So that's a second time. It's just a wording thing. The question might ask you for limiting reagent, in which case you would say sandwich, or it might say which in excess, in which case you have an extra step to do. You got to figure out what's limiting and then pick the other one. Okay? And the next one is, this is the hardest one. Determine the amount of excess that was left over. Now in this case, you could look and say, oh well, if I can only make 5 sandwiches and I'm going to use 10 slices of bread, so I've got 2 slices of bread left over. Well, you can see where that would be important in the real world. When you use up a reagent, you need to know how much of how much you have left over of the other material. Why is that? Well, because you need to know how much, if you need to order some more or not. Right? If you've got to make 100 sandwiches and you do the math and you've only got 2 slices of bread left over, you got some left over, but you need to order some more. On the other hand, if I started with 120 slices of bread, you'd still have a whole lot of bread left over and you probably wouldn't order anymore. So it's not just trying to be difficult. There is a reason, a good reason why to calculate how much excess reagent you have left over. Let's look at what a problem looks like. Okay, so let's you have 5 grams of magnesium dioxide. Okay, I'm going to find magnesium dioxide. Now I'm going to go ahead and write my 5.00 there. And I have 7 grams of sulfuric acid. 7 grams of sulfuric acid. Okay. How much water can you make? Okay, and this is what I'm looking for. How much water can I make? Okay, the first thing I noticed, this is what I have 2 stars. Oh my gosh. So the question is, box equals star. Which star are we going to use? Well, 5 has less. No, that's not the right. That's what has the less starting material. No, what you want is, the limiting reagent is the ones that produces the least amount of material here. When it says on the other one, the thing that's in least supply, what it means is the thing that's in least supply with respect to making the least amount of product. You have to calculate this to find out which of these is in least supply. Okay, right. So what do we have to do here? Well, we have a little bit of an issue then, don't we? Because we got to go from grams of this to moles of this to moles of this to grams of this. And I want to see how much of this, how much water I can produce. Just like I did it, I just did the mole thing here, but just as I did it for bread. Just as I did it for bread. And then what am I going to have to do? I'm now going to have to do it also for H2SO4. Grams of this to moles of this to moles of that to moles of that. Just like I had to also do it for meat here to get both of these, so I could compare how much of my final product is made. It is only this answer that told me which material was limiting. Okay, so in essence, here's all you have. You just have a stoichiometry problem where you got to do it twice and pick the smaller number. That's what you've got. That's as hard as limiting reagent really is. At least this version of it where you don't have to calculate excess. So let me walk you through that. And again, these are also practice for what we've already learned, but we've already gone over it so many times. Let me let the wheel of death stop here. Maybe. Good. Okay, so let's walk you through it. Let's do the green one, right? How many grams of water, box, do I get starting with 5 grams of this? So I'm going to work the green line now. So I'm going to go what? From grams of mag oxide to moles of mag oxide. And then from moles of mag oxide to moles of water. And then from moles of water to grams of water. And that's what I'm looking for. Grams of water. Okay. So when you work that out, however you want to punch it on your calculator, I normally just go left to right. I actually follow this thing. So I would have punched 5 divided by 60, 86.9 times 2 times 18. Where did I get this? The periodic chart. The weight of 1 manganese and 2 oxygens gives 60. Where did I get this 1 to 2? For every 1 mole of manganese dioxide, I get 2 moles of water, okay? And then where did I get this? For every 1 mole of H2O, I have what? The weight of 2 H's and 1 O, which is 18. So what I did with calculating the green line from manganese oxide, I calculate I will produce 2.07 grams of water. How about my other one? Going to do the same thing. Now I'm going to start with my 7 grams of H2SO4. And I'm going to go from grams of H2SO4 to moles. From moles of H2SO4 to moles of water. From moles of water to grams of water. Same thing. This column, always periodic chart. This one, the balanced chemical equation. Notice there's a 2 and 2 this time. Why? Because I'm looking at the H2SO4 and there's 2 there and there's 2 there. So that's why it's 2 there. The mole. So that's the mole ratio. Okay? So when I do this, what do I wind up with? Starting with this 5 grams, I can actually produce 2.07. Starting with 7 grams of this, I can only produce 1.28. Why? Because it's consumed twice, even though there's more. 7 grams is more than 5. Look at the 2. It's being consumed twice as fast. So how much am I going to produce? Well, let's look. So what is my limiting reagent? My limiting reagent is this. Is the one that gives me 1.28, which is the acid. Yes, so that is my limiting reagent. That is my limiting reagent. Okay. Which one is in excess? I know the one that's in excess is this. Why? Because it produced more than the minimum. So this is the material that's in excess. Okay, so that's your first 2 types of questions that I told you about. An easy question would be, what's a limiting reagent? Your answer would have been sulfuric acid. Next type of questions, determine the excess reagent, which in this case was the manganese dioxide.